So when you have a question, the first thing you need to find is the claim. So go right away to the claim. The claim that the mean symbolic, mean, right? So it must be talking about mean. So right away you're gonna have mu1, mu2, mu1, mu2, right? And then systolic blood pressure for vegetarian is lower than the mean, so it's lower. So vegetarian, you have to check your data. Vegetarian is data number 1. So mu1 is lower than mu2. So mu1 is lower than mu2. This is your original claim. That's the first step. Give me your answer. I don't want to do it. So
oh yeah, you're doing it. I wasn't even paying attention to that. Okay, go ahead.
Okay. So you have your claim already, right? So you just go to statistics. But you need to decide if this one is sigma known or sigma unknown, right? Because when you do, where's the paper? The chapter 9 paper. So when you do the mean, you have either sigma known or independent or dependent, right? So for sure it's not dependent. So it's either sigma known or sigma unknown. So you look at this, you read it again, independent sample error, you the following sample statistic, and then they give you the standard deviation for each one, blah 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 blah. So they're not giving you any sigma here.
Right.
So it must be the sigma unknown. The sigma unknown. So you go with t-test score. Instead of t-score, you're going to do t-test score. So your calculator formula is going to be 2 sample t-test. So you go to your calculator, test, 2 sample t-test, and then you input the data that they gave in the question. $85, 138.7, 39.2, and 75. And then put unfold. Less than. Calculate. So you got your t-score over there and the p-value. So now the only thing is you need to find your critical value. So your test statistic is your t-score from the calculator. And then the p-value, you can find it in the calculator too, right? So your critical value...
And degrees of freedom of 155.
So if you draw it like this, you have left tail, right? Because it's less than. So you have a tail over here. And the area after that tail is your alpha. Your alpha is this one, 0.01, right? So you have to find what's the critical value over here. So how to find it? You're gonna use you don't have inverse here. You're gonna use the table.
On this too, our P is equal to our significant level too. Because if you run that up, to 0.01. So you know how you test your alpha and your P? Like what happens when it's equal?
This is still less than 1, right? It's still less than 0.01.
Okay, so then it's smaller. Okay.
So when you treat it, it's
you reject it.
To find the critical value, you know your degree of freedom is n-1, right? So n, choose from the lowest n. You have 85 and 75, right? So you're going to choose 75.
Okay.
So your degree of freedom is 75 minus 1. And then you look at the table A3. Table A3. And then your area, 75, right?
Now I'm going to go to 80.
Yeah, and then 0.01, this one. So that way you find this one. 2.639. No? Do they have this one?
No. You're doing this one, right?
345.
Mm-hmm.
34.
See, there's degrees of freedom of 200 or 100. Is this the same one?
It is the same one. Total area is one term. You can use
Okay, negative 2.36.
2.381 is over here. 2.364 is
They're going with this one.
364.
Yeah.
And 3.45?
Mm-hmm.
2.345?
Yeah, these two.
Ah, because they
But why are they
both.
They combine them?
You're gonna pick the lowest one, which is 75.
But they have it as... This is confusing.
Okay. Wait, I thought you said he's not doing full. Okay, so what he did over there, he adds both of the n and then minus it with 2. But that one is for pool, the pool one.
Okay.
I thought he said he's not doing pool. Okay, pause.